Now let us talk about the regulation of the glycogen. How glycogen is regulated in our body. So glycogen is regulated in the various ways. So first there could be the allosteric regulation and there could be the hormonal regulation. Also there is a specific role of the calcium that helps to regulate the glycogen. And after regulating the glycogen, there is the steady level of the glucose in our body, even after in the well fed state or excessive fed state, or even when we are in starving state. If there is regulation of glycogen, then there will be the steady level of the glucose in our body. So because how it does is that if there is excessive fed stage or well fed stage, due to the various mechanism of the regulation of the glycogen, the excessive level of the glucose is converted to glycogen and stored in liver. Whereas if there is fasting stage, the glycogen that is stored in our body is converted into glucose 1 phosphate, and it goes into various other carbohydrate metabolism like glycogenolysis, which ultimately converts the glycogen to glucose. Now let us talk about the regulation of the glycogen. So before starting the regulation of the glycogen, I want you to know the various steps of glycogenesis and glycogenolysis. As I have already told you that in the glycogenesis, the rate limiting enzyme in the glycogenesis is conversion of the conversion of the glucose 1 phosphate to glycogen, where there is involvement of the enzyme glycogen synthase. Where there is involvement of the enzyme glycogen synthase, that is the rate limiting enzyme. And in the glycogenolysis, the rate limiting enzyme is glycogen phosphorylase, where there is conversion of the glycogen to limit dextrin by the glycogen phosphorylase. Now knowing these steps, knowing these rate limiting enzyme, the various allosteric factors act upon these enzymes to regulate the glycogen. So as I've already told you, there is allosteric regulation and there is hormonal regulation of the glycogen metabolism. First we are going to talk about the allosteric regulation of the glycogen metabolism, and then we'll talk about hormonal regulation of glycogenesis and glycogenolysis. So as you know that the glycogen is converted to glucose 1 phosphate by glycogen phosphorylase, and glucose 1 phosphate is converted to glycogen by the glycogen synthase. First of all, we'll talk about this reaction, conversion of glucose 1 phosphate to glycogen by the glycogen synthase. So in the well fed stage, there is increased availability of glucose 6 phosphate, and this glucose 6 phosphate enhances the action of the glycogen synthase. So if there is enhancement of the glycogen synthase, there is conversion of the glucose 1 phosphate to glycogen. That means in the well fed stage, there is more conversion of the glucose 1 phosphate to glycogen, and eventually this glycogen is stored in the liver. So ultimately the glucose 6 phosphate, the increased availability of glucose 6 phosphate increases the action of the glycogen synthase, which ultimately increases the conversion of the glucose 1 phosphate to glycogen. Now another step is the conversion of the glycogen to glucose 1 phosphate. So what happens is that how it is regulated. The glucose 1 phosphate, if there is more availability of glucose 1 phosphate, then it itself inhibit the enzyme glycogen phosphorylase. It itself inhibit the enzyme glycogen phosphorylase, and there is less conversion of the glycogen to glucose 1 phosphate. Also, the more availability of ATP, if there is more availability of ATP, then it will inhibit the enzyme glycogen phosphorylase, and there will be the less conversion of the glycogen to glucose 1 phosphate. Also, if there is excessive amount of the glucose in the liver and in the body, then it will inhibit the glycogen phosphorylase, ultimately inhibit the steps conversion of the glycogen to glucose 1 phosphate. Also, the calcium and adenosine monophosphate AMP increases the glycogen phosphorylase. That means if there is increased availability of the calcium and adenosine monophosphate, then it will increase the action of the glycogen phosphorylase. That means there will be the more conversion of the glycogen to glucose 1 phosphate. So what are the allosteric activators of the glycogen phosphorylase? The allosteric activators of the glycogen phosphorylase are calcium and adenosine monophosphate, and allosteric inhibitors of the glycogen phosphorylase are glucose 1 phosphate, ATP, and excessive amount of the glucose in the liver and body. What are the allosteric activator of the glycogen synthase? The allosteric activator of the glycogen synthase is glucose 6 phosphate. So this is the allosteric regulation of the glycogen. Now we are going to talk about the hormonal regulation of the glycogen, how glycogenesis and glycogenolysis is regulated by the hormones. Now we are going to talk about that.